there. So in this tutorial, we are going to learn how to add and subtract rational expressions. But before we proceed to these examples, we must be familiar first on how to add and subtract simple fractions. Why? Because in adding and subtracting rational expressions, we follow the same process as to how we do it in fractions. Now remember, when we are adding and subtracting fractions, we have two cases. The first one is for the similar fractions. We say that fractions are similar if the fractions have the same denominator. And we call it dissimilar, which is our second case, if the denominators are not the same. Now we also have the same concept when we are adding or subtracting rational expressions, because we also have the what we saw called similar rational expressions, wherein the denominators are the same as well. And we also have one which is for the dissimilar rational expressions, wherein the denominators are not the same. Let us know first, how do we add similar rational expressions? Okay, so let's begin with this example. So we have 6 over x minus 5 plus x plus 2 over x minus 5. So what we need to do first is to copy the common denominator, which is x minus 5, and do the operation with our two numerators. So we have 6 plus x plus 2. Now let us simplify our numerator. So we have x plus, combine 6 and 2, that will be equal to 8, all over x minus 5. Now the question is this now our final answer? If you think that your rational expression can no longer be simplified, then that means that that is already your final answer. So since we can no longer simplify x plus 8 over x minus 5, then this is now our final answer. Okay, let's move to our second example. So we have here x squared plus 3x minus 2 all over x plus 5 times x minus 2 plus 4x plus 12 over x plus 5 times x minus 2. Now let us copy the common denominator, which is x plus 5 times x minus 2, and then combine or add the two numerators. So we will have x squared plus 3x minus 2 plus 4x plus 12. Now let's simplify our numerator. So x squared, we do not see any similar term with this one. So x squared will remain as x squared, and then combine 3x with 4x. That will give us positive 7x. And for the constants, we have here negative 2 plus 12. So combining negative 2 and 12, that will give us positive 10 all over x plus 5 times x minus 2. Now if you will notice, we have quadratic trinomial in our numerator, and we can still factor this one out. So the factors of this are two binomials. So we will have x here, put x here, and then for 10, we have two options. We can use 5 and 2 and 10 or 1. 10 and 1 rather. But since what we need to use is something that is related or somehow connected to 7x, which is our goal to be our middle term, so therefore let us use 5 and 2. So let's use 5 and 2 instead. Now, why not negative 5 times negative 2? Again, our goal is positive 7x. So what we need to use are both positive instead. So all over x plus 5 times x minus 2. Now look at our factors. We can now cancel out one pair of x plus 5. So we will be left with x plus 2 over x minus 2. And this is now our final answer. Okay, this time for our third example, let's do it in subtraction. So we have x squared minus 2x plus 3 over x squared plus 7x plus 12 minus x squared minus 4x minus 5 over x squared plus 7x plus 12. So again, we need to copy the common denominator, which is x squared plus 7x plus 12, and do the operation indicated for the numerators. So we have x squared minus 2x plus 3 minus, take a look at this, we need to include this or enclose rather this numerator with a parenthesis to mean that we are subtracting the first numerator by this whole second numerator, which is x squared minus 4x minus 5. Because if we will try to not include parentheses, that means that we are only subtracting 3 by x squared, but that is not our goal here. So we want to mean that we are subtracting all of this. Okay, now let's follow our rule in subtraction, wherein we are changing the subtrahend into its opposite. So let's try to do that one in this example. So x squared minus 2x plus 3, and x squared is positive, so it will become negative. And if it is negative, the operation can be simplified as subtraction. So minus x squared to mean that your x squared is negative. And for 4x, since we have subtraction here, that means that 4x is negative. So changing it into opposite sign, so 4x will be now positive, which will indicate addition. So plus 4x. And for the last one, minus 5, to mean that 5 is negative, so we need to change it into its opposite. So this will become positive 5. So we will have plus 5 here. All over x squared plus 7x plus 12. So this time, let's simplify this numerator. So we will have x squared. Wait, let's use another color. So x squared minus x squared, that will give us 0. So it will be cancelled out. Now for negative 2x plus 4x, that will give us positive 2x because these are unlike sign. And for the last one, we have positive 3 plus 5, that is equal to 8. All over x squared plus 7x plus 12. Now let's try to factor it out, or let's try to factor both numerator and denominator to see if we can still simplify it further. So in the numerator, we can do common monomial factoring. We can factor out 2. So 2x divided by 2, that is x, and then plus 8 divided by 2, that is 4. And for the denominator part, x squared plus 7x plus 12, we can factor it this way. So put x here, and then for 12, we have different factors of 12. We have 3 and 4. 3 times 4, we have 2 times 6. We have 1 times 12. But the pair which is near to our goal, which is our middle term, or equal to our goal, which is 7x. So we must be using 3 and 4. So both positive, since our middle term is positive. So now look at your numerator and denominator. We can cancel out x plus 4. So we will be left with 2 over x plus 3, which is now our final answer. Okay, so for our next case, we are going to learn how to add and subtract the similar rational expressions. And to do this one, we need to recall how do we add and subtract the similar fractions. And let us use this example. So let us say we have 1/4 plus 2 over 6. Now if we encountered the similar fractions, we need to make it similar, and to do that, we need to find out its LCD. So we need to get the LCM of 4 and 6 to know this LCD. Now how do we get LCM of 4 and 6? First is list down the factors of 4. Aside from listing method or listing the multiples 4, 8, 12, etc., etc., 6, 8, etc., etc., and then looking for the smallest one, you can do this method. So get the factors or prime factors of 4, that is 2 times 2, and for 6, that is 2 times 3. Now we wish to look for the smallest possible number that is divisible by this number 4 and 6. And if we say so, that also means that this number must be divisible by these factors. So it must be divisible by 2, both for 4 and 6. It must be divisible by another 2, and it must be divisible by 3. So we need to get the product of these 3, and we will have 12. Can 12 divide 4? Yes. Can 12, or rather, can 12 be divided by 4? Yes. And it can also be divided by 6. So therefore, this one now is our LCD. So let's use 12. After getting the LCD, divide 12 by 4, that is 3 times 1, that is still 3. 12 divided by 6, that is 2 times 2, that will give us 4. So now we can follow our step in adding similar fractions. So copy 12, and then 3 plus 4 is 7. So this is now our answer to this problem. Now let's try to do the same process when we are dealing with rational expressions. So let's have some examples. Let's start with the simplest one. 1 over 5 plus 1 over y. So we need to find out the LCD first. Okay. And then between 5 and y, its factors are 5 and 1. Factors of y is only rather y and 1. So it needs to be divided by 5 and can be divided as well by y. So get the product of 5 and y, that will give us 5y. So therefore 5y is our LCD. Or if you do not see any common factor between your denominator, just simply proceed getting its product. So we will have 5y and 5y here. So let us now do the next steps. 5y divided by 5, that is y times 1, that is still y. 5y divided by y will be cancelled out, so we will be left with 5, and 5 times 1 is 5. So there we will have common denominator, which is 5y, y plus 5 for the numerator. So this is now our final answer, since we can no longer simplify this one. Okay, let's have another example. This time, let's do subtraction. So let's say we have 2 over x squared minus 3 over 7x. So we need to get first the LCD. Okay, the LCD. So what is the LCM of x squared and 7x? Let's find out. So x times x, and then for this one we have 7 times x. So it must be divisible by x, and it must be divisible by another x, and by 7 as well. So that will give us a product of 7x squared. Okay, and then after doing this, we now have our LCD, which is 7x squared. So we will use that here. And then after that, 7x squared divided by x squared, this will be cancelled out. So we will be left with 7 times 2. Multiply it by 2. So we will have 14. And then for the next one, 7x squared divided by 7x, we will be left with x times 3 times 3, that is 3x. So now we will have this expression, 14 minus 3x over the common denominator, which is 7x squared. So this is now our final answer, since we can no longer cancel out some common factors. Okay, let's move on to our third example. So let's have 1 over 18x cubed times y plus 5 over 27 27x squared y cubed. So we need to find out the LCD before we proceed with addition. So let's list them out here. X cubed y, 27x squared y cubed. Okay, so this can be expanded as 2 times 3 times 3 times x times x times x times y, and the other one can be expanded as 3 times 3 times 3 times x times y times y times y. So we need to make sure that it is divisible by 3 squared and another 2 and another 3 and x squared and another x and another for y and y and y. So 3 copies of y. So that will give us a total of, let's simplify it here. So this is a total of 3 squared is 9 times 2 is 18 times 3, that is 54. And then x squared times x is x cubed. And then y times y times y is y cubed. So this is now our LCD. 54 x cubed y cubed. Okay, now let's do the next step. So 54 x cubed y cubed divided by 18x cubed y, we will be left with 3. Wait, let me write it here. So we will be left with 3. X cubed will be cancelled out. Then y, we will be left with 2. So 3y squared times 1 is 3y squared. And then for the other one, we will have 54 divided by 27 is 2. X cubed divided by x squared is x. And y cubed divided by y cubed, so that will be cancelled out. So 2x times 5, that is 10x. Now to simplify this one, so we will have 3y squared plus 10x all over 54x cubed y cubed. Now can we still cancel out something? Not anymore. So this is not, this is now rather our final answer. Okay, so let's have the last example. The fourth one, we have 5 over x minus 7y over x plus 3. So take note, x here is part of the expression or a term. It's not a factor. Because if this is a factor, the operation in between x and 3 should be multiplication. So x will still be x times 1. Then x plus 3 will still be x plus 3. Factor of x plus 3 is x plus 3. To mean that these are already prime factors. So we can simply get its product for the LCD. So x times x plus 3. So let's stay it this form so that if we can see something in common, we can already cancel it out. So we no longer need to factor it anymore. So there. So we have that LCD. X times x plus 3. So x times x plus 3 divided by x. So x will be cancelled out. So we will have to multiply it by 5. So 5 times x plus 3 here. Minus x plus 3 x times x plus 3 divided by x plus 3, so this will be cancelled out. So we will be left with x times 7y, so we will have 7xy. So let's simplify it further. So distribute 5, so we'll have 5x plus 15 minus 7xy over x times x plus 3. And look at our numerator. We can no longer do some common monomial factoring or other factoring techniques. So therefore, this is now our final answer. Okay, so that will be all for our discussion regarding this topic, addition and subtraction of rational expressions. I hope you learned something from this tutorial. Thank you so much for watching.